How does a dung beetle find its way around? Even though it is walking backwards in the dark and rolling a large ball of dung, it moves in a perfectly straight line.
I mean, dung beetles in themselves are highly fascinating. They can do the most amazing things. They can make dung balls, they can roll dung balls, and they can also steer incredibly straight.
But just how does it succeed? That is what Marie Dacke is working to find out.
Before I started looking into the navigation abilities of the dung beetles, nothing was known really about this. I went in that direction to study their visual system, but then gradually we started to understand how incredibly fascinating they are as navigating organisms. And we are just, moving further and further into this wonderful world of the beetles.
A dung beetle eats animal poop, like elephant dung, for example. To have its food all to itself, it forms the dung into a ball and rolls it away, as far away from where it was discovered as possible, to avoid competing with other dung beetles. And the most efficient way is to travel in as straight a direction as possible.
If they have set out to move in one direction, they will keep on going there, even if there is a hurdle in their way, if they fall into a little pit. They're not going to turn around. They will spend hours trying to move in that direction.
Initially, dung beetle research wasn't an obvious choice for Marie.
All children, or at least most, are really fascinated about animals around them. I was maybe more fascinated than others, and that hasn't left me until this day. I am still highly fascinated about creatures around me.
Is it feeding you?
Yeah.
During her education, Marie focused on animal navigation systems. And it was when she accompanied a colleague on a research trip to South Africa that Marie discovered that the dung beetle was a perfect research partner.
Yes. So dung beetles are fascinating as creatures because you think you're going to test one thing, then the animal or the insect in this case is going to do something completely different. And then you have to be very creative to find a new angle how to look at this process. So it's really, really a creative challenge to ask the right question to understand their answer.
But how do dung beetles steer so straight? Marie and her colleagues attach measuring devices to them to be able to study exactly how the dung beetles move. For example, how it turns around a few times to calibrate itself against different landmarks in its environment. Marie has discovered that the dung beetle uses the sun, the moon, the wind, and even the Milky Way.
The last piece of us understanding that this was actually the case was done in the planetarium, where we could turn off stars and turn on stars. And we finally understood that these beetles are using the Milky Way. That was not known for any other animal before. It was such a relief when we finally cracked how they navigate using the night sky.
Not only does Marie want to understand what dung beetles use to navigate, but also what happens inside the dung beetle's brain and within their nervous system. Using X-rays and other high-resolution microscopes, they scan the dung beetle's brain and create a detailed 3D reconstruction of what it looks like. In nature, a dung beetle must constantly prioritize and choose what to use for navigation. The sun, for example, is a good guide when it shines from the side, like in the morning. But in the middle of the day, when it's directly overhead, this beetle must choose another component in the environment to navigate by. But how does this choosing actually happen?
In many ways, I imagine the beetle solution to navigation is like having different levels in their head. So one can be the sun compass. It's like, okay, now I'm going to trust my sun compass a lot. And when the sun becomes unreliable, it can disappear behind a cloud, for example. Then they take down the importance of this compass, and then they can raise the importance of the wind compass. And what the rules are for how they modify the networks, that is something that we really try to find out in this project. So this is the retina, the light-sensitive part of the eye, and this is then the outer surface here, so we can actually now define its curvature.
And this knowledge can open up new opportunities for us humans as well.
For a beetle to be able to navigate, it uses sensors, and then it's processing the signals. It is in many ways very similar to what lots of our technological inventions need to do. So if you look at the eye of a beetle, it is effectively a light sensor, but it's tiny, tiny. Still, it can extract very, very good information from the world around it. It is also very, very interesting to understand how the beetle combines different sources of information. To all calculations they do, they need to be very smart because they have very little computer power. And understanding how you solve a problem in the most straightforward way, that is something that really fascinates us in moving forward.
Of course, the little dung beetle knows nothing about this. For it, life just rolls on, ever forward. Much like Marie in her relentless research.
In some ways, I actually feel kidnapped by the beetles because I've tried to move away from using them as model systems on a few occasions. But every time I do this, something new happens and a new amazing discovery is being made. So I've kind of accepted by now that I will be hanging out with these animals for at least another 10 years to come.